Welcome everyone. How are you all? I hope you all are good and you have enjoyed your Sunday with a bit of games, bit of studies. Everything is going on. Okay, so we will start another lecture of oscillations. In the previous lecture, if you can recall, we have studied about equation of SHM. What is the velocity of the particle during SHM? What is its acceleration? When this velocity is maximum, or what is the magnitude of maximum velocity? What is the magnitude of maximum acceleration? What is phase? What it describes? These were the things that we have already studied in previous lecture. So in today's class, what we are going to study is this. First of all, we will have a very simple recall the concept. We will have some recall of the previous lecture. After that, there is a recall test. Uniform circular motion and SHM, we will discuss about that. Energy of the body in SHM, and then the potential energy and kinetic energy curves. There will be a concept test and a homework question. So that's it for today's session. Okay, so we are going to start with some recall. Okay, okay. First of all, I will recall a few things that you should remember, or I think you know about those things. What are those things? First of all, you should know what is the equation of SHM. If I say, what is the equation of SHM? Then you will say the equation of SHM is either X or Y. You can write it in any way. So X is equals to A sine omega t plus phi. In this equation, A is the amplitude, omega is the angular frequency, phi is the initial phase, and this complete omega t plus phi is phase. Clear? I think this is the very known thing. Now, you can differentiate it to get velocity and again differentiate it to get the acceleration. That's up to you. You can get those equations as well very easily. Now, if I talk about another thing, that is how we have represented SHM. We have represented SHM like this. A particle moving along this path, or you can say oscillating along this path about a mean position, which is called x equals to 0. All the distances or displacements are to be measured from this point only. And this is the maximum or extreme position. This is A. This is left side extreme position. This is minus A. So particle moves along this path like this. This is the motion of the particle. And starting from here, if it completely reaches there, then it's called one oscillation. That's how we describe SHM. Now, another thing that you should know, the acceleration of the particle is always towards the mean position. That what we have learned. I am just recalling the basic things. What I'm saying, that acceleration of particle is always towards the mean position. Does it imply that velocity of the particle is always towards the mean position? Can anyone answer? Does this statement imply that velocity of the particle is always towards the mean position? Can anyone answer? You will say, no, sir. It doesn't imply that velocity of the particle is always towards the mean position, because when particle is moving along the positive x-axis, the velocity is along the positive x-axis, but the acceleration is towards the mean position. So velocity may or may not be towards the mean position, but acceleration is always towards the mean position. That's one thing. Clear? And this acceleration is proportional to negative of displacement. This negative sign shows towards the mean position. These were the basic things that we have discussed. Now, another thing that we have discussed is maximum velocity. Maximum velocity. What is the maximum velocity? You will say V max is equals to A omega. You need to remember this is the relation that we have derived already. So maximum velocity is A omega. A is amplitude, omega is angular frequency. And at which position velocity is maximum? You will say at mean position. So maximum velocity, if you need to remember two things. The velocity is maximum at mean position, and the magnitude of this maximum velocity is A omega. Another thing is maximum acceleration. Maximum acceleration. Again, you will say that maximum acceleration is what? The relation is minus A omega square. Minus is again showing the direction towards the mean position. So A max is minus A omega square. Another thing, when it is maximum at extreme positions. So you need to remember at least these things before moving further. I think everything till now is clear. Okay. So I will move further. So on the next slide, there will be a question, a recall question for you. Try to solve it out. Recall test. Okay, this is a very famous question actually, and you should remember the result as well. You should remember the result. One thing that is more I can recall you, if I say for SHM, one more thing that you can remember. For example, SHM is between these 2 points. This is the mean position, x equals to 0. This is the maximum displacement, A. This is the maximum displacement on the left side, that is minus A. And the particle is moving. Let's suppose particle is moving from mean position. First, it reaches A. Then it returns back and again reaches mean position. Continue move, reaches minus A and returns back to the mean position. So there are 4 steps. You can see that. Step 1, step 2, step 3, and step 4. Can you see these? We have broken this one oscillation in 4 parts. From mean position to positive extreme, from positive extreme to mean position, then from mean position to negative extreme, again from negative extreme to mean position. And what I'm saying that all these 4 steps are identical in terms of time. All these 4 steps are identical in terms of time. What I say, what I'm trying to say, that is, if in part one, or you can say time taken in part one is equals to time taken in part two is equals to time taken in part three is equals to time taken in part four. This is again a very good punchline actually. We have broken one oscillation in four parts. You can remember easily remember these four parts. You can fragment this. And in all these four parts, time taken to travel in all these four parts is equal. And if total time taken is t, the time taken to complete one oscillation is what? T. This is known as time period. Then this time is equals to t by 4. One part, two part, three part, four part. All four parts take equal time, then one part will take t by 4 time. And you can directly remember this result. This is a very common question that may come in your objective question or your multiple choice questions. So you need to remember this result. All these four parts are identical. Clear? So till now, the things that were written, this is just a recall thing. I have recalled you some basic concepts. Now there is a recall test. Try to attempt the question. You have some, I will say, 1 minute time for this. Try to read and solve. Okay. I hope you are solving. What it says, a particle executes SHM of time period t. Okay, so time period is given. The time taken by the particle to go directly from its mean position to half the amplitude position is. Okay, so they are asking about the time. Okay, let's suppose particle is executing SHM. Clear? This is the mean position. This is x equals to 0. This is the maximum position or extreme position, which is A. Okay. Now they are saying time taken by the particle to go directly from its mean position to half the amplitude position. So can you see that they are asking about the time taken to reach from this point to this point, and this distance is what? A by 2. Clear? Half the amplitude position. So this time is being asked. Clear? We will find that time. There is no problem. So now remember one thing. Remember one thing. I will give you some standard results, but before that, try to remember one thing. What I am saying, that general equation of SHM is x is equals to A sine omega t plus phi, where phi is the initial phase, or someone may call it phase constant. It depends on the initial point or start of the point from where the particle starts motion, or in other words, the position at which you start watching the motion. Is it clear? Phi depends on at which time or at which position you started watching the motion. So they are asking me from x equals to 0 to a by 2. So what my think is, the first thing that will come in mind, that I will choose this point as t equals to 0. Because I am concerned about this time. I am concerned about this time. So what I will do, I will start my time when the particle is at mean position. So that's what I am saying. The time is 0 at mean position. So if I put these values in this equation, I will get phi. I will get phi. We will remember that result forever after that. So I am putting at t to 0, particle is at mean position. Is it true? I have considered time equals to 0 at mean position. So at t0, x is also 0. If I put this in equation number 1, what I will get, 0 is equals to a sine omega t plus phi. And in this relation, if you can see, t is also 0. What I will get sine phi because t is 0. Okay. So can you see that from this relation, sine phi is 0? That means phi is equals to 0. So what we got what is phi? Phi is 0. So the equation will become x is equals to a sine omega t. Now what you will remember or what you should remember, whenever the particle starts SHM from the mean position or at the mean position, then you will get phi 0. If any particle is starting SHM from the mean position, then its equation will become a sine omega t. That's the final thing you will get. So you should remember that whenever particle starts motion from the origin or from the mean position, its equation will be simply a sine omega t. There is no phi because phi will become 0. Okay. Now they are asking me the time taken to reach a by 2. Let's suppose time is t, then x is equals to, now I am again placing the value a by 2. The distance, that displacement they are talking about is a by 2 is equals to a sine omega t. A will get cancelled. What you will get? You will get sine omega t is equals to 1 by 2, or you can say omega t is equals to pi by 6. Sine inverse 1 by 2, which is pi by 6. So t is equals to pi by 6 omega. Again, if I talk about t is equals to pi by 6 and omega is what? 2 pi by t. Is it clear? So pi and pi will cancel out. T will become t by 12. So t by 12 is which option? Option number C is the correct answer. T by 12. So from the next time, if I ask you, calculate the time in reaching the mean position from the extreme position, then you will take t equals to 0 at this point. At which point you will take t equals to 0 from where the motion is going to be started. That's what we have learned. And if particle is starting motion from the mean position, then its equation will be x equals to a sine omega t. Clear? Is the question clear to you? So we will move further. Uniform circular motion and SHM. Now again look at that. Have a look at that. Let's suppose a particle is moving in a circular path. like this. The particle is moving in a circular path. Let's choose some axis. Let's suppose this is our x-axis and this is our y-axis. Clear? And one more thing that I am going to suppose here. Let's suppose particle is here at point P at time t equals to 0. That means initially particle is at P. Is it clear now? And it is moving in the circular path with some angular velocity. I will say, let's suppose the angular velocity is omega. Particle is moving in this circular path. Till now, everything is clear. Now you have to visualize the things. You will have to visualize the things. What I am trying to say, consider a particle revolving in circular path. Now, can you see that if this is the center of the circle O, then this y-axis is a diameter and x-axis is also a diameter. Now, what if I say that there is a light coming? The light is coming from this side. And at the place of this y-axis, I have placed a screen. I have placed a screen. Clear? And light is coming from this side. And this is a screen. Then the particle, there will be a image of the particle. You can say there will be a image of the particle. Na? You can say that there will be an image of particle at this point. This is going to be the image of particle. Is it clear? Everything is clear now. Now, if particle moves further away, it is revolving now. It is moving in the circular path, then particle will sometime reach there. Then its image will be here. Can you imagine this thing? Can you imagine this thing? That image will be here. Similarly, when particle reaches here, the image is again here only. In the same way, if I say that light is also coming from this side, then when particle reaches there, let's suppose moving, it reaches here. Then its image will be here. When the particle is here, the image will be here. Can you see the motion of the image? No, I am not saying that see the motion of the particle. See the motion of the image of the particle. And you will say the particle is revolving on the y-axis. Particle is moving on the y-axis between these 2 points. Between these two extreme points, particle is moving. And if we consider this motion, I will describe it with some equations. If we consider this motion, then it will represent a SHM. It will represent SHM. So one thing that is very much clear here, what is the connection of uniform circular motion and SHM? I will say there is a connection of uniform circular motion and SHM. The image or the projection of particle on the y-axis or on the x-axis, or you will say on the diameter, represents SHM. Represents SHM. So conclusion is that the projection means, you know what is projection? When we throw some light, this is called projection. The image is called projection. the projection of particle on the diameter executes SHM. Is this thing clear to you? Now I will delete all the diagram, the portion containing all such things. I will remove them so that we can draw these relations, draw these equations. Okay, so let me redraw it. I will look at that. And there was a y-axis as well. Like this. Now what I am saying, let's suppose initially when particle was at P at t equals to 0, it makes an angle phi. It makes an angle phi with the x-axis. Is it clear now? After that, it is moving with some velocity omega. It reaches a point P dash. Let's suppose it reaches a point P dash when at time t. Clear? Now it makes an angle. What the angle will it make? What the angle will it travel in this time? You will say its velocity is omega, time is t. Then in this time, it will have traveled or it must have traveled an angle omega t. It must have traveled an angle omega t. So the projection of the particle on the diameters represents SHM. So I will draw the projections. I will draw the projections. Can you see that this is the projection? This is the projection. Clear? Let's suppose at any time t, this distance is x. This distance is x. And can you see that when this particle moves in the circular path, the projection will change on the x-axis? And the projection will change on the x-axis. So this is a time-dependent thing. And this is a time-dependent thing. Then I will say in this triangle O, P dash, and let's suppose this point is something Q. In triangle O, P dash, and Q. Clear? Let's suppose the radius of the circle is A. The radius of the circle is A. So OQ will be what? OQ will be the base. So base is what? Hypotenuse into cos theta. And the total angle is hypotenuse is OP dash cos theta is what? Omega t plus phi. So what you can write, OQ is what? X is equals to A cos omega t plus phi. This is the equation of x projection. Projection on the x-axis. Now, in the same way, if I see the projection on the y-axis, if I see the projection on the y-axis, then this projection will be like that. And this distance will be y. Then if you calculate y from the triangle OP dash, let this point is R. Then from the triangle or in triangle OP dash R, y will be what? Y will be A sine omega t plus phi. So these two equations shows that part projection of the particle on x and y axis or on the diameter represents SHM. Is it clear? The projection of the particle on the diameter represents SHM. Is it clear? Now, one more thing that I will discuss here on the next slide, I am going to discuss. This is just a punchline. Try to remember this. If particle starts from mean position, if particle starts from mean position, then its equation will be either x or y. You can choose anything. I have chosen x on the x-axis, y on the y-axis. In all the cases, the equation will be x is equals to a sine omega t. Try to remember this in your mind. If particle starts from mean position, then its equation will be a sine omega t. Another thing, if particle starts from extreme position, then its equation will be x is equals to a cos omega t. Then its equation will be a cos omega t. Can you remember these two things? Now, moving further. Energy of the body in SHM. This is again a very fundamental thing. Again, I am saying, what is energy? When you say, let's suppose, take an example of SHM. Let's suppose a body is executing SHM. Which body? Let's take a body like this, a spring mass system. The mass of the system is, mass of the block is m, and the spring constant is k, and the surface is smooth. It is executing SHM. And what we did, we have extended it, or this particle is executing SHM in this way. And at any instant, let's suppose it is displaced, or it is at a distance x from the mean position. It is at a distance x from the mean position. Clear? So we need to calculate the energy of the body in this situation, in this position, or at every position. What is going to be the energy? This is our task. Okay. So the first thing that I will say, that energy of the body will be in two forms. Two forms what? It is moving, that means it has some kinetic energy, and it is a spring mass system. There is a restoring force acting on it, so it will have some potential energy as well. So there will be two forms of energies, that is potential energy plus kinetic energy. Clear? So we will calculate potential energy and we will calculate kinetic energy and put it here, and we will get total energy. Is it clear? Okay. So now, first of all, we will calculate potential energy. You know that potential energy of a spring mass system is what? Is half kx square. Don't say that you don't know about this. This is the basic fundamental relation that we have studied in work energy and power. The potential energy of the system is half kx square. Here x is what? X is nothing but equation of SHM, position of the particle, and which is given by A sine omega t. If the particle started motion from the mean position. For simplicity, I am just taking this value. I can take omega t plus phi as well, but which will create some complexity, or it is difficult to write it again and again. You can replace the omega t with omega t plus phi anytime. So there is no issue with that. So you will become half k, x is what? A square sine square omega t. Is it clear till now? One more thing, you know that omega square is equals to k by m. We have studied that in this relation. Omega square is equals to k by m. So k is equals to m omega square. Replace this value. So it will become u is equals to half. K is what? M omega square A square sine square omega t. This is what we get potential energy. You can see potential energy is also a function of sign. Potential energy is also a function of sign. You can see that. I will come to this point later. Now again we will calculate kinetic energy. Kinetic energy is what? Half m v square. Is it clear? Now I will put the value of v here. So kinetic energy will become half m. V is what? If you differentiate it, you will get v, and it will be a square omega square cos square omega t. So we got kinetic energy, we got potential energy. Now we need to put these two values in equation 1. From equation number 1. What we will get? Total energy is equals to, if you put u and k here, then you can see something is common. Something is common. So I will take it common, half m omega square a square. And what will get? What will be remaining term? Sine square omega t plus cos square omega t. Which is 1? So what we will get? E is equals to half m omega square a square. So now listen to the conclusion part. Listen to the conclusion part. What is the conclusion? Or what are the equations that you should highlight? You should highlight all these 3 things. 1, that is potential energy. 1, that is kinetic energy. And this is total energy. So what is the things to be highlighted? What are the main things? The potential energy is a function of time. The kinetic energy is also a function of time. Is it clear? Both potential and kinetic energies are the function of time. But total energy is independent of time and is a constant. So what we can say, during SHM, total energy is constant, or you can say total energy is conserved. This is the point that we can conclude from here, that potential energy varies with the time, kinetic energy varies with the time, but total energy remains conserved. Is it clear? So on the next page, I will summarize this. What I can say, total energy in SHM remains conserved. Is this point clear? Total energy in SHM remains conserved. One more thing. If I draw the potential energy and the kinetic energy curve, that you can see that let's suppose this is the particle executing SHM and I am drawing the kinetic energy curve. This is kinetic energy and this is going to be the position X. Let's suppose this is minus A and this is plus A. Particle is executing SHM from this point to this point. Clear? Now, what will be the kinetic energy curve? You can say at extreme position, you can see the equation here of kinetic energy. This is the equation of kinetic energy. At extreme positions, the velocity of the particle is zero. You know that. That means at extreme position, the kinetic energy will be zero. And if you draw the curve, it will look something like that. This is a parabolic curve. This is a parabolic curve. Try to remember, this is a parabolic curve. The kinetic energy versus position graph is a parabola, and at the extreme position, kinetic energy is zero, and kinetic energy zero is maximum at the mean position. Clear? Now, again, if I draw the curve for potential energy, how it will look like? This is potential energy, and this is again position. This is, let's suppose, minus A, and this is plus A. And if I draw the curve, it will look like that. Again, this is a parabolic curve which shows when kinetic energy is minimum, the potential energy is maximum. And when kinetic energy is maximum, the potential energy is minimum. Is it clear? And the combination of two is always constant. And the combination of two gives total energy. And the combination of two gives total energy. And this total energy is a constant. And this total energy is a constant. I can draw this again. This is total energy. This is again position X, minus A and plus A. The combination of these two is a constant. And this constant value is half m omega square a square. Is it clear? So these were the curves of potential energy and kinetic energy. Moving further. So there is a very basic fundamental concept test that I will take here. Okay, I will not discuss this one. It will be discussed, or very easy question actually. This question is nothing but the question that I have discussed about uniform circular motion. You can solve it in your homework. You can solve it in your homework. Okay. Try to solve it out in 1 minute. You have 1 minute to solve this question. Comment the answer either A, B, C, or D. You have 1 minute. Can you answer? What we have seen is that during SHM, the mechanical energy remains conserved. So if we know that mechanical energy remains conserved, then we can apply the mechanical energy conservation. What the diagram says, I will describe it to you. Let's suppose they are saying a block whose mass is this one is fastened to a spring. Fastened means attached to a spring. The spring has a spring constant, this one. Okay. If it crosses the center of oscillation with a speed this much, the amplitude of motion will be. Okay, let's suppose this is the spring. This is the block. And again, let's suppose this is the mean position, x equals to 0. When it is at the extreme position, this is I am saying x equals to a. Clear? This is spring constant k. Mass of the block is m. So what is this? What is the basic principle? Let's suppose this is initial position, this is final position. And during the motion, I know that mechanical energy will remain conserved. So I will say K initial plus U initial. This is what initial energy is equals to K final plus U final. If you put K initial at this point, you know the velocity. You know the velocity. So that is half m v square plus at the mean position. At the mean position, you will say potential energy is 0. How the potential energy is 0? Because extension in the spring is 0. Elongation or compression, whatever you can say, the change in the length of a spring is 0. That means potential energy is 0. Finally, at the maximum position, kinetic energy is 0 because it will have no velocity. Answer is A. Okay. Ganesh. Okay, let's check. And at the final position, potential energy is what? Half k a square. You can see that half will cancel out, 1 by 2 and 1 by 2 will be cancelled. Mass is 0.5, velocity is 10, 10 square means 100 is equals to k is what? 50 a square. Okay, you can see this is 50 and 50, so a square is 1. So a is 1 meter. Very good, Ganesh. The amplitude is 1 meter. Very good. I think the question is very much easy. Moving further, there is one more question you can take. I think this is a similar kind of question, not very much difficult. Again, you can take 45 seconds or around 50 seconds, I will say, to solve it out. I'm waiting for the answer. So I'm waiting for the answer. If I talk about, you need to find the equation of SHM. And if you need to find the equation of SHM, what is the general form of equation? You can say X or Y, whatever you can say. X is equals to A sine omega t plus phi. This is the general form of equation. So what is phi? Phi is the initial phase, and initial phase is given as pi by 4. So that means phi is given. Amplitude is also given. That everything is given here. What you need to calculate? You need to calculate omega only. If you can calculate omega, you will get the answer. So for the calculation of omega, they have given its kinetic energy. And kinetic energy, when the kinetic energy have given, passes through the mean position. That means at the mean position, kinetic energy is given. Okay, Ganesh is saying option D is the correct answer. Okay, let's check. And I hope so that D is correct. So kinetic energy is at the mean position is given. At mean position, you know that at mean position, kinetic energy is maximum. That is equals to half m v square. Or you can say V max. Kinetic energy is maximum at the mean position, and this value is given as 8 into 10 raised to the power minus 3 is equals to half. M is what? 0.1 kg, I think. V max is what? A omega. V max is what? A omega. You know that V max is A omega. So you square it, A square, omega square. 2 will come here. It will become 16 into 10 raised to the power minus 3 is equals to 0.1 into A is what? 0.1. If you square it, it will become 0.1 raised to the power 2 omega square. Can you see it? This is 10 to power minus 2 and 10 to power minus 1. That is 10 to power minus 3. These two terms will combined cancel 10 raised to power minus 3. So omega will be 4. And you can place omega and phi here. So if you place x is equals to A is what? 0.1 sine omega is what? 4t plus pi by 4. I think the answer is correct. Answer given by Ganesh is correct. So option D is the correct answer. Very good. Uh, Time for the session is up. So there is one, or I think two homework questions are there. Try to note this question out, and I will give you 1 minute. I will give you 40 seconds if you can answer it. However, this is your homework question. Can you answer it? And there is one more homework question. I think have you read it clearly? Because I am going to end the session now. There is one more question that you need to do is this one. Try to note down the questions and solve it. There are two circular motions for which you need to write the equation of their SHM. So I am ending the session here.